First thing we did is we multiplied polynomials. For the most part, we multiplied binomials by binomials. So I might have x minus 2 times x plus 3. And this is a binomial times another binomial. That's where we use the box to multiply these. Okay, so when I'm multiplying, I'd have the box, and I use the outside when we're multiplying, we know the outsides, and we multiply to get the insides, or all the areas. We also talked about multiplying a binomial times a trinomial. When we have a binomial times a trinomial, that just changed the number of boxes that we have, right? Because now I have two things being multiplied by three things. So your setup is a little bit different. So now I'd have x minus 2, x squared minus 3x plus 4. I can multiply to get all the insides from there. All right, last thing I want to mention is when we have three things that are being multiplied, I think a good example of that would be if we had like x minus 3 cubed. If I have x minus 3 cubed, remember that means that x minus 3 times itself 3 times. So that's x minus 3 times another x minus 3 times another x minus 3. And when there are three things being multiplied, we got to multiply two of them together. So we would take two of these x minus 3s. We'd multiply those together. So that'd be a 2 by 2. Then I would take that product and multiply it by the last x minus 3. And that's going to be a bigger set of boxes because now we're going to get a binomial times a trinomial. All right, and the last piece that you'll have to kind of decide is when am I being asked to multiply? And it should say it, right? It'll say find the product. Okay, when we have to multiply, it should be pretty clear and pretty obvious. So this is how we started the unit, right? This is how we introduced the area models. We said, hey, these area models are a really good tool for us to be able to multiply all these terms together. Then most of what we did is we reversed this process. We said, hey, if I have a polynomial that is in its standard form, can we reverse the multiplication and factor it? Okay, and this is kind of the main focus of what I wanted to do with this back page here, and that's factoring. So let's first make a note that factoring is the reverse process of multiplying polynomials. Right? And it's not always the most obvious thing. So that says factoring is the reverse process of multiplying polynomials. So in a way, factoring is division. Yes, we're not actually using like long division or any sort of formal method of division that you've done previously, but it still is a way of division. Then the factor. And the one thing that I cannot emphasize enough, step one, is to always, let's capitalize this, look for a GCF. Okay, Cannot emphasize that part enough. Sometimes that'll be the only thing you need to do. If you factor out the GCF, you might be done. Other times, it just makes the rest of the work that much easier. Okay, but this should always be our first step regardless. The next thing that you're going to have to decide is, what am I trying to factor? Am I factoring a quadratic or am I factoring a cubic? Because it happens a little bit differently. Okay, so step 2, do we have a quadratic? Question mark. Or do we have a cubic? Here's how we can tell the difference. Quadratic means that we have an x squared term. Okay, so it's ax squared plus bx plus c. What defines it as quadratic is the largest exponent of 2. If we recognize that we are trying to factor a quadratic and we've looked for a GCF, this is where we need to find the 4th term. Right? Having 3 terms is a problem. So we would start by finding 2 numbers. Let's do this off to the side. 2 numbers that add to b and multiply to a times c. Let's call those number 1 and number 2. And so when we find these numbers, that's how we get to have 4 terms. Because now we go from ax squared plus bx plus c to ax squared plus number 1x plus number 2x plus c. So that bx splits up into those 2 terms. And now there are 4 total terms, 1 for each place in the box. So ax squared, always in the top left. Constant term, always in the bottom right. And then the other 2, it does not matter. So number 1x and number 2x. You got the sheet right there. And then you need to find the outsides to do the factoring from there. All right. All right, last one is, if we recognize that it's not a quadratic, instead we think it might be a cubic. Cubics are going to be in the form of ax cubed plus bx squared plus cx plus d. What defines this as being cubic is this exponent of 3. Having that exponent of 3 and it being the largest exponent defines that as being cubic. When it's cubic, now I have 1, 2, 3, 4 terms. We don't need to do any extra work. This is ready to go straight into the box. And we're on our way. So ax cubed, bx squared, cx, and d. And you've got to find the outsides to be able to factor it. And then we're all done. All right. That's everything on this page is everything we've done in this unit. Okay, and then we've just gotten a ton of practice, okay, with all these different variations within this. So as you study, use this page. Okay, if you get stuck, use this page on top of the notes that you already have. Your test is very similar in length to what this review is. And you know what? I don't have anything else to share. So I will be quiet. I will let you all get some work done. The only thing you need to do is be productive. And when you hear your name, bring your binder to me. I'm going to do a homework check. If you have questions, also bring them up to me. Let's make sure we're productive.